Question 4.48. A mass m1 equals 20.0 kilogram on a frictionless ramp is attached to a light string. The string passes over a frictionless pulley and is attached to a hanging mass m2. The ramp is at an angle of theta equals 30.0 degree above the horizontal. M1 moves up the ramp uniformly at constant speed. Find the value of M2. So here you have masses M1 and M2 attached with the help of a light string that passes over a frictionless pulley. The mass M1 moves up the ramp with a constant speed, let us call it V. And since M1 and M2 are attached by the same string, M2 has to move down with the same speed V. We need to find what is the value of mass M2 when M1 is given as 20.0 kilogram and the angle with which the ramp is raised is 30 degree. So let us begin by showing the forces acting on these masses. Mass M2 is hanging from the pulley and is moving downward with a constant speed V. The first force that we will show on M2 is force due to gravity Fg, which is vertically downward. We write this as Fg2. And then you have the tension in the string, which is pointing towards the suspension point. Then we do the same thing for mass M1. M1 is moving up the ramp, which is an inclined plane. And we need to show the x and y axis for this incline. For an inclined plane, the x-axis lies along the length of the incline. So this will be my x-axis parallel to the length of the incline. I call this x. The y-axis will be perpendicular to x. So we draw a perpendicular line to x-axis and call it y. Then we will show the forces acting on mass m1. First, we will show the force due to gravity, which acts vertically down. We call it Fg1. Then we show the normal force acting perpendicular to the surface of the ramp. We call this N. And then we have the tension in the string pointing towards the point of suspension. This is my tension T. And since the ramp is frictionless, we don't need to include the force of friction here. So these are the three forces acting on mass M1. My normal force is along the y-axis, whereas the tension force is along the x-axis. The force due to gravity, on the other hand, lies neither on the x-axis nor the y-axis. So we have to split this force into component. One component that goes along x-axis, we call this Fg1x. And the other component that goes along the y-axis, which we call Fg1y. The y component of gravity makes an angle theta with it, which is the same angle as the angle of incline. Now we know for an inclined plane, we can give the x and y component of gravity as Fgx to be equal to mg sine theta and Fgy will be equal to mg cosine theta. And that is because it is the y component which is adjacent to the angle theta. And any side which is adjacent to the angle theta, we associate that side with cosine. And the x component is away from the angle theta, so we will relate the x component with sine. After we draw all the forces acting on masses m1 and m2, we will write the equation of net force for both of them. So let us start with mass m2. Mass m2 is moving down with a constant speed v. And if it is moving with a constant speed, that means acceleration a has to be equal to 0. If acceleration is 0, the net force acting on mass 2 will also be 0. So F net 2 will be equal to 0. The net force acting on mass 2 is the vector sum of all forces acting on it. Here we have two forces, the tension T in the string and the force due to gravity Fg. And we are going to take vector sum of these two forces to write F net. When I say vector sum, we add these two forces, but we take their sign into consideration, with the convention being all forces going up, we take them positive, Forces going down, we will take them negative. So we write F net 2 to be equal to T minus Fg2 equals 0. T is positive because it is going up. Fg2 is negative because it is going down. We know we can write Fg as mass times acceleration due to gravity. So let's substitute that here. T minus m2g equals 0. m2 because this is for mass 2. Now move m2g to the other side. We get T equals m2g. We will call this equation 1. Now let's do the same thing for mass 1. Mass 1 is only moving along the x-axis as it goes up the incline. There is no motion along y-axis. So we will only consider the forces along x. Again, since mass 1 is moving with a constant speed v, acceleration a is equal to 0. And if acceleration is 0, the net force acting on that mass will also be 0. So I write F net 1x equals 0x because we are only considering the forces along the x-axis. Again, we can write the net force on mass 1 by taking vector sum of all forces along x-axis. Along x-axis, we have two forces here, Fg1x and the tension in the string. And through convention, the force to the right, we take them as positive, and the one going to the left, we will take them as negative. So we write T minus Fg1x to be equal to 0. That gives me T to be equal to Fg1x when we move Fg1x to the other side. Fg1x is equal to mg sine theta, so we write T to be equal to m1g sine theta. We will call this equation 2. Now, if you notice equation 1 and equation 2, both of them are equal to the tension T in the string. And since the left-hand side of both equations are equal, that means the right-hand side has to be equal to each other. So we write equation 1 to be equal to equation 2 and then substitute the values here. Equation 1 right-hand side is m2g. For equation 2 it is m1g sine theta. I want to find what is m2. So we can cancel off the g here. That gives me m2 equals m1 sine theta. M1 is 20 kilograms, so let's substitute 20 times sine of the angle 30. That gives me M2 to be equal to 10 kilograms.